Welcome back, and today I think we'll mix a bit of theory and some practicals. Now, I wanted to bring you to the idea of circuits because when you look at any appliance or that is working, it's simply a circuit. But in the circuits, we normally deal with things such as voltage, and voltage, like we told you earlier on, is the power source, which at times we call potential difference. And then next we deal with currents. That's what flows through the device to cause work. And then of course resistance. Devices always have a resistance value. Now we want to take you through those concepts and demonstrate them, and then also take you as far as to do with measurements of those values. Now of course that brings us to the idea that we will need instruments to take measurements, and now if we were going to measure voltage, we would need a voltmeter like we mentioned earlier on. So we will demonstrate that in this video for you to know that voltage is the voltmeter, that's the instrument used. And then when we go to current, the instrument used, we already mentioned it even in earlier videos, that it's the multimeter. We'll demonstrate how to use that. And then later on, resistance. Resistance also are the things you will measure, and in that case you use an ammeter. And as such, we are going to demonstrate those things in this video. Now first of all, let us recap that voltage, here we are looking at the potential difference, the source of potential difference, and at times we just call it voltage. And then for us to illustrate this and how they influence the amount of work, we shall create a simple electric circuit. And I think that's where we come to the practicality. So we are going to first connect a simple electric circuit, which we will have a source of voltage, and then we will have a source of resistance, that's the load, the thing that we want to do work by giving it a source of power. And then we will measure the current that will be flowing in that circuit. By the way, when I say work or voltage, these are things that are almost close to each other, because you all know that energy is never destroyed nor created, it just changes form. So we are using one form of energy to produce another form of energy, the other form of energy being the work that we require to be done. For instance, we give it voltage, and then that's usually coming from chemical source of energy, which is converted to maybe heat or light, and that's another form of energy. So basically that's what happens in an electric circuit, one form of energy being converted into another. So right now I think we'll begin with a simple load, and a load, we will look at something like this bulb, which we mentioned earlier on is a form of resistor, and we shall show you how to measure that in subsequent videos. So that will show us the demonstration of how to use an ammeter. And then this source, we're going to use batteries, and let me just indicate that. So here we are looking at a battery that is a combination of cells. And then here we are going to look at a bulb, an incandescent bulb. So we are going to commence from there, and first we need to attach some wires to the ends of these bulbs, this terminal and that terminal. This terminal goes to that when you look at that tiny thing at the center, that's a tungsten resistance wire. As we said, we shall measure its resistance. That one end of it connects to this and one end connects to that. So since it's hard for me to work with it this way, and that we covered soldering, I'm going to have Nathan solder 2 wires to that. Now I want the red wire at this bottom terminal and then the black wire on that terminal. So let me hand over to him as he does that, because I want him to demonstrate some of the things we've been covering. And since he has been here physically, he is our dummy. Please proceed.
Okay, thank you for this opportunity. Let me proceed from here. Okay, we get, and then we first add some of this here. Okay, let us first put the wire. You have to get a nice position to solder this. Let me try this. Okay, the black terminal.
You let me know when you're done connecting.
This. So I think we should put some flux on this. Okay. Let's put that out of the way and we add some. Okay. A nice position and then right, so I think we are done here.
Okay, so that was a recap, and this shows me that he is able to solder now. And why I asked him to solder is because we need that in our demonstrations. And we're going to begin by making a simple circuit to just demonstrate for you the idea of voltage. With the small one. So let's first talk about this without dealing with the idea of measurements yet. So right now we're just going to connect a simple circuit in which we attempt to light a bulb. Now the bulb is the load, the device that needs to consume electricity, and then the source of the electricity in our case is going to be the dry cells, and we are using dry cells. I know. Okay, so we are going to take this terminal as our positive terminal and this as our negative terminal, in as much as these incandescent bulbs do not have any direction. You give it power to glow because it's simply a resistance wire. But because in future we will be dealing with positive and negative terminals, I need to introduce you to that idea. Now we have here a dry cell. This is a Panasonic dry cell, and this one can create a potential difference of about 1.5 volts. I think it should be indicated somewhere there, 1.5 volts. And this side is the negative and this side is the positive. Or in our case we can say this is 0 and that's positive 1.5. But across this there's a potential difference of 1.5. Now we have another cell here, but for now I need to connect this to the resistance, to the resistance that we have here, which is a bulb. But before we do that, I need some bit of black background. Alright, so let's bring that black to give us some sort of background. Now this is the positive terminal and we are going to connect it here. Meanwhile, you might look at the bulb. When we put the positive here and then we put the negative there, we should get a glow. I think you can see a tiny glow there, like that. So 1.5 volts is causing current to flow through that bulb and we get off light. Now whenever we increase the potential difference, that means even the amount of work done increases, because the bigger the potential difference, the bigger the current that will flow through that bulb, because this resistance value, the value of this bulb, is considered constant. Now let me just demonstrate that. So this was 5 volts here. When I add, this was 1.5 volts, not 5. This was 1.5 volts. When I add another 1.5, remember I connect the positive to the negative, so that when we add 1.5 to 1.5 we have 3 volts. Now look at the bulb and the amount of light we get. It increases because we are increasing the amount of power being supplied. We are increasing the potential difference. Now let me bring a third one. These are all identical batteries. I expect the glow to even be much brighter. I think you can see. Now because I am out of the same type of cells, I'm going to add these two, but just to confirm to you, they are also written 1.5 volts and 1.5 volts, so they also create a potential difference of 1.5 volt. Now it's going to be a bit harder for me to hold these three, but let me bring some bit of capsule like that to help me contain it. Now I'm going to put that in there, that in there, then that in there. Now I want to bring the fourth one in there, and then also pay attention to the amount of glow that we get when we connect this to the ends of meanwhile this is 1.5 times 4, which is 6 volts. You can see that the glow is even much bigger. Now this bulb is rated for 12 volts. That means it shines brightest at 12 volts, or that's what the brightness required from it should operate at. Where's my last battery? And now put them up to, these are how many cells?
9
These are 5 cells. 5 cells times 1.5 gives that 7.5. So at 7.5, how much glow will we get connecting these seaming tiles? So that is 7.5 volts. You can see the glow. Let me reduce it. That's 6. Reduce it. That's 4.5. Reduce it. That is 3 and 1. So I have just demonstrated to you that the bigger the voltage, the greater the amount of current that flows, and therefore the greater the work done. In this case, the work that is being done is converting the chemical energy into light. So this bulb is producing light. Of course, in the future, you'll realize that as it is producing light, it's actually heating up. So it produces both light and heat, but we cannot show you heat right now. The obvious is light, in as much as it brings out more heat, but the light is the thing. It's like that resistance wire is burning to create for you light, but burning without dying. Now, we have just showed you that when we increase voltage, the amount of work done in terms of brightness is increased. Now, we also told you that this is simply a resistance wire, and I think at this point, let me just demonstrate also that when we increase the resistance, the amount of brightness in one bulb reduces. So what I'm going to do is, because this is a resistance, that means, let me just recap a little. So this is what we did here right now. This is what we would call a circuit. A circuit. And in this case, it's a closed circuit. Closed in that current flows and keeps rotating through it. When I do this and break this contact, this is basically what a switch would do. It completes the circuit. And when I remove, I've broken the circuit. Complete it, broken. So when I break the circuit, it's called open circuit. No current is flowing. When I close or complete the circuit, it's called a closed circuit. So circuit, current is flowing through until these cells that are creating the potential difference run out. Now, I have another identical resistance wire. So I expect these two to be of the same resistance value. Now I'm going to add this into the circuit to just increase the resistance and show you that it actually causes a reduction in the work done, in terms of we will have reduced brightness from each bulb or from that bulb. Now let me take it back to hour 6 such that the effect is easy to see. So let me take it back to hour 6 volts. That means I'm going to use 4 dry cells. Okay, so I am going to first demonstrate for you here with only 4 cells with only 1 bulb. That's the amount of brightness that we are getting. I know our background is trying to run. Thank you. So that is, so to increase resistance, I'm going to connect this one's positive terminal to the other one's negative terminal, right, and then bring it in circuit. So this is a continuous loop. My thing is trying to run away. Okay, help me there. I need them to see also the wire to show so that it is completed like that. And then okay, now I want you to look at the brightness we get from that when we've added another resistance in series. You see, it is dim. Each of them lights very dimly, very dimly. Now let me remove the other one. That's the brightness we get when it's only 1, meaning that these 6 volts are all creating a potential difference across that tiny resistance wire. So it causes it to glow brighter because more electrons are able to flow through it, doing more work, creating more light. Now when we increase the resistance, like we had taught earlier on, it's like increasing security guards that are supposed to stop people from accessing certain entrance. The brightness reduces, like very little current flows, and therefore very little work is done in terms of creating light. Yeah, so that is more resistance, less resistance. Anyway, I think I've demonstrated that. Sorry, my setup is a bit quirky. Now that is to tell you that we have dealt with 3 things here: circuits, which we said can be open, that's with no current flowing, or closed with current flowing. And then we have talked of the more the voltage, the greater the work, which was light. And when we increase resistance, there's less light or work done. So that is the effect of resistance, because we said resistance reduces the current flowing, and we know that when the more the current flowing, the more the work that is done. But for more current to flow, we need a higher potential difference. That means we need more power. So here we're using 4 cells to create a total of 6 volts of potential difference, whereas one was only 1.5 volts of potential difference, and it caused very little glow. When we added the second one, the glow increased. When we added the third one, the glow increased. When we added the fourth one, the glow even increased more. And when we added the 5th one, we reached 7.5 volts, and it was the brightest we saw here on video. Now, what do we do? The next thing is I want to show you how to measure those items: voltage, current, and resistance. So I am going to use a voltmeter to measure voltage, and an ammeter to measure current, and an ohmmeter to measure resistance. Now, unfortunately, I don't have them individually, but I have this machine called a multimeter because it has the voltmeter, it has the ammeter, it has the ohmmeter. So it has different settings for you to choose each of these. Now, since we are beginning with voltage, I am going to, you see here, so batteries normally have direct voltage or direct they are direct current sources. Now, because current only flows in one direction from them, that's why they are called direct current voltage sources. So that means I am going to put it in voltage mode. I'm going to choose 20 because the voltage we are going to measure is not going to exceed 20. Remember, we added and we're only reaching 7.5 volts, so that's why I've chosen this. Now, this is the voltmeters part of this multimeter. This here is the current measuring part, which is our ammeter. When I point this that side, I'm in ammeter mode. When I point this side, I'm in voltmeter mode. And then this part here that you see are in ohmmeter. I think you might have already noticed the V for voltage, and volts are the units of voltage or potential difference. Volts, and then this is amperes, that's denoted as A, and then this is in ohms, that is denoted by that omega sign. It's a Greek letter, omega. So from this part to that part, that's ohmmeter. From that part to that part is voltmeter for direct current voltage sources, and then that is ammeter, direct current in amperes. This part we won't use it today because this is for measuring voltage AC, but we are only dealing with this voltmeter for direct current, this ammeter for direct current, and this ohmmeter. Now, there are two terms we shall get familiar with in this video, that is parallel and series. The series simply means that it's passing through one thing before reaching the other. So if I had a pipe here and then another pipe here, then another pipe here, if I pushed in water from here, it will first pass through this, then go through that, then go through that. So these are in series. But if I had a pipe here and a pipe next to this one, and I supplied water from this end, it will both pass through this and come out at the same time. This is parallel, to be side by side. So that will help us in the concept of connections. Now, whenever we are measuring voltage, we connect the voltmeter. Pay attention, we're in voltage mode. We connect the voltmeter, the probes, parallel to the device. So let me just get this. Now, I just wanted to show you that this truly is 5 volts. So the red probe is the positive terminal and the black probe is the negative terminal. So bring this, let me hold that down, it's rolling. So we bring this to that terminal and this to that terminal, and you can see that it's reading approximately 1.5 volts that we told you. When you round it off, that is 1.5 volts. Okay, it's showing 1.46, and that's because when you connect a load to it, which was our bulb, it starts draining power from this, and its ability to create a potential difference starts dropping. So it becomes capable of creating a potential difference of 5, in other words 5 volts, and it keeps reducing as you take power out of it. Now that's 5 volts. I need to also confirm to you that the other one is also 5 volts. So we are going to measure all of them. Okay, this one has dropped 1.37. We can still approximate that to 5. Then this one is still a high, 1.47. And also to confirm to you that these ones are the same volts as the other one, 1.49. These are still quite high. From 1.5 it's reduced to 1.4549. And then this, okay, that's still at 1.5. Interesting. Then I also want to confirm to you that voltage tends to add up. Now I'm going to connect these two in series and then show you that this 1.5 and 1.5 should total to a total of 3 volts. Okay, 2.97 rounded off, that's 3. So we are going to also prove that 3 of them is 1.5 times 3, which should be roughly 4. Roughly 4.5. It's hard to connect them. Let me take advantage of my pipe right there to just help me with this. I don't know whether you can see it in frame. Okay, help me hold the pipe. Now let me rotate that, and that's 4.36. we expected 4.5. That's close. Now I'm moving it to the 4th cell, and that comes to 5.86. we expected 6, and that's close. And then we put the 5th one, we expect 7.5. That's 1.5 times 5, and what do we get? 7.34. So that's just to show you that these dry cells, when you put them in series, the voltage across builds up. And this is what I was telling you. This is a series. They're in series, flowing through this, then that, then that, then that, like that. So that is when the dry cells are connected in series, the voltage adds up. Now, having said that, assuming we already have a circuit connected, how would you measure the voltage and current across? Now, what I'm going to do is I'm going to keep this tied together and put wires at the extreme ends to make it easy to work with or handle. Okay, anyway, what I'm going to do, I'm going to reconnect this circuit. Now, because I needed to show you the next thing, which is how to measure current. But before that, let me show you how to measure ohms. That's the resistance, because that one is a little easier to demonstrate than me measuring current. So let's begin with that and just confirm the resistance of this thing. Now, also the other thing you need to know, when you're measuring resistance, just like voltage, you connect it across what you're measuring. in other words in parallel, they be side by side. So I need to set it to resistance, which I can choose any. Let me say I expect it to be roughly 200 kilo ohms. That K means kilo, meaning 1000 multiplied by 1000. So 200 times 1000, which is 200, you add 3 zeros, so that's 200,000 ohms. Now I'm going to put one probe here. The resistance usually doesn't have direction, so wherever I put, it will give me a value. Okay, that means the resistance I'm trying to read is smaller than that. That's why I cannot get a value. Let me try to drop it down, and we see still small. Okay, so this is corresponding to that. So this would mean that 2 is in the thousands, so that's 2000 ohms. Let me first drop it to 200 and see if it will give me a value. Okay, anyway, that's how you measure the resistance across. I'm starting to doubt my multimeter a little. Let me cross check with another one. Okay, so I want to measure that resistance. Oh, I need to first change my thing to resistance mode. So yeah, and told me it's roughly in the range of the thousands. This one is unwilling. Okay, let me try to use this to measure voltage, and I see if at least its voltage setting, we expect it to give us roughly something close to 1.5. So put the black at the negative terminal and the red at the positive terminal. Okay, it is good for measuring voltage. Now we've shown you how to measure voltage using a voltmeter, and then we've shown you how to measure resistance using an ammeter. Now we are going to show you how to measure current with an ammeter. And unlike voltage and resistance, when you're measuring current, since we are looking at electrons flowing through the circuit, it has to be connected in series. So power comes in through here, flows through the ammeter, goes to the bulb, and then back to the battery, and like that in our circuit. So what we are going to do, I'm going to connect the positive of the ammeter to the negative of our bulb, the negative we've chosen. Okay, now that it's connected, it is connected there in series. So we need a dry cell. Now I'm also going to take this opportunity to tell you that whenever we increase the voltage, the current flowing increases. So I'm going to begin with one cell. When we put two cells, one cell is 1.5 volts, two cells becomes 3 volts, 3 cells becomes 4.5. So I'm going to connect this to the positive terminal of our cell, and then I need my bulb in circuit because I need to see that it is glowing, that current is flowing through it, and also look at the ammeter to see that current is flowing. Oh, we had forgotten to put it into current mode, ammeter mode. So let us say we are measuring up to that amount of current. That is this is milli. If you didn't know, milli means divide by 1000. So that would mean this is 0.2 amperes. But then if we wanted to measure up to a higher current of 10 amperes, then we would have to move this probe to that hole. But right now, I don't expect this to deliver more than that, but I could be wrong. Let's just try that and see. Okay, put this bulb battery here and then connect the bulb. Do we get a glow? We get a current reading. So we are getting about 126. Is it glowing? Oh yeah, it's glowing but dim. Don't know whether you guys can see. Are you able to see? So it's glowing. So what's happening here, I don't know whether you can see my circuit, and I have to turn my ammeter into that state. Okay, if I wanted a positive value, I would just reverse this terminal like that. Okay, let me do just that. Let me bring the red. Let me connect it this way. Our black to our red. Because I want to use positive values. But even though that's the case, let me use the other multimeter for current. Okay, anyway, this is good for current. It's okay. Let me proceed with this one. The other one, we'll use it for voltage. Let me connect the circuit again. Hope I've not confused you by reversing the wires. And I just wanted it to give me a positive value here. So that means if it is a negative value, just reverse which wire you connect where, as long as the ammeter is in series with the circuit. So this is that. So I'm going to put the positive terminal there and the negative terminal there. So we are getting a glow at the bulb. Wow, it's very hard for me to fit everything under the camera. And pardon me if you are unable to see. Try to provide a black background there. And wow, Nathan, I think I need your hand. Help me hold this from shifting. Okay, and then that. And the problem is my wires are stiffer than should be. So I'm going to connect the negative terminal here. Help me look at the bulb if it glows, and then also help me look there for the current reading that it reads. Oh, it is glowing but dimly, and it tells me 125 milliamperes are flowing. That is because we've set it in the milliampere range, measuring up to a maximum of 200 milliamperes. Now, pay attention to the brightness and the amount of current that will be flowing. Like I told you, we've connected this in series. Yeah. Also remember that current is coming out of the positive terminal of the battery, passes through the multimeter, or in this case ammeter, and then comes out through the black terminal, runs through the bulb, causes the bulb to glow, and then comes back to the negative terminal. Now give me a blue one. Let me increase the potential difference by increasing the cells to 2. That means from 1.5 volts of potential difference, we are going to 3. Now you see the glow has increased. It is brighter, and the multimeter reads a higher current. It's now 184 milliamperes. Yeah, so that means increasing voltage increases the amount of current that is flowing, and therefore more work is done in terms of more brightness. Now we are moving to 3 cells, which brings the voltage up to 4.5, and the glow is brighter. Now it's giving me 1 because that means it's beyond the range that we are trying to measure. Our maximum current we're trying to measure was 200 milliamperes, but we saw that only 2 cells could, at 3 volts, could bring the current to 180 milliamperes, very close to that. Now I'm going to shift this probe so that we can measure up to 10 amperes. Now that we have said that, let's begin by first proof checking with this. Now that one rounds off the value 100. Okay, now let's put the 3rd cell. Alright, the brightness increases and the current it is reading is now okay, let that not confuse you. Let me first put that there at the 10 amperes such that I don't have to deal with decimal points. Earlier on we said 2 cells was giving us 184 milliamperes. Wow. Now since we are on the knob that is at 10, so whatever value we get there is in amperes. Actually 184 milliamperes is 0.18 because we just divide that by 1000. Okay, which it is giving us there as 0.19. It has rounded off the two decimal places right there, 0.19. Now let us increase the cells to 4, and then here we get higher brightness and the current steps up to 0.24 amperes. Now let's go to 4 cells. 4 cells. Will I still be able to hold them with one hand? Right. The current jumps up to 0.28. So that's to show you that whenever you increase the voltage, the amount of current increases, and the amount of work done by the moving current increases. So we get more brightness. So that means we have covered 3 or 4 things in the broader sense. Now at times when these are already connected in circuit, it's also, you can just measure the voltage across by just putting the voltmeter there. Now because I am unable to hold these cells, it may be harder for me to demonstrate, but let me try and see. Try to get Nathan to hold them for me. Now I want you to put this terminal at this end and that end. No, yeah, okay. Right, it will reach, don't worry. Put this there. You put the wire there. So it's glowing and it is consuming 0.32 amperes. Now as it is consuming that, I want to get the other voltmeter and take measurements of the voltage reading. Let me move this down there and then turn this to voltage reading and read the maximum of that. So I'm going to put this in parallel to this cell so that it gives me the reading of the voltage across only this cell. How do I get in between there? Need something pointed. So I'm going to replace my okay, let me just attach it there like that so that I can reach down there. So your circuit is not complete, like that. Now measure the voltage across this. When power is flowing, you see it's dropped to 1.07. So when current is flowing, the voltage drops. But let me also measure the voltage at the bulb, and see it is dropped to, because remember we are supplying it from a 7.5, it is dropped to 6.5. That's because current is being drawn. And so I've just demonstrated that when you're measuring voltage, the voltmeter has to be in parallel.
I have a question.
And then the ammeter has to be in series. In series, in the sense that current comes, passes through the ammeter, and then continues to the bulb, and this way. Yeah, you can ask.
Yeah, there is no like energy gained or lost here, weight in the multimeter.
It is very tiny. The multimeter doesn't consume much. You may find it is consuming 0.00 something milliamperes. But of course it also, because it has some little resistance inside which is very small, it will consume some little power, but very little. What is actually causing it to display is not this current flowing. It already has a battery that runs the display. So what it is displaying is just, it's tapping a bit of the current and then sees how big it is, and then the one inside powers the IC to show you the value. But if it was the so-called moving coil ones, they would consume more current, because the same current that is being measured is also what causes the needle to deflect. Yeah. Any other question? So I think to summarize this video, as he is holding, we have told you that whenever you increase the voltage, the amount of current flowing increases, and that causes a much brighter glow. And then we've said that how to use this equipment. An ammeter is connected in series with what you're trying to measure. In other words, if this was connected, this wire of the bulb was connected to the battery, you would cut it and then use the ammeter to join it to that time. So that current first passes through the ammeter, then through the bulb, so that it can pick it and measure it. Whereas voltmeter, right there, you don't need to cut or break the circuit. You just tap at the terminals like we had said earlier on. Just bring the probes and measure, and it will give you a voltage value. Now, and then also we showed you how to measure resistance. You use the ohmmeter. But now resistance, you measure it when there's no power flowing. So that means I'll have to first disconnect this from circuit to measure its resistance. So you measure resistance when the item is not being supplied power, because you just want it, and you connect the ohmmeter in parallel to the device, like across there, and then it gives you a value. Anyway, hit the subscribe button. It has been a long video. I hope it makes sense. I think we'll come with more refined videos later on. I think tomorrow I'll have Nathan recap what we've covered today, just to see if he has understood how to measure these values, and also how increasing this affects that, and how this affects that and that, because we've demonstrated it here. I don't expect you to forget. So anyway, see you in the next video of Pierce Laboratory.